We're always looking for big energy solutions, right? But what if the answer is like right in front of us?
Yeah.
What if we could get energy just from the air?
The air.
Yeah, just pull it right out of thin air.
Crazy.
Well, not so crazy maybe, because today we're going to take a deep dive into these standalone atmospheric energy collectors.
Oh, cool.
See if they can really work and how they might be built.
That's a great topic.
It is, and we've got some interesting sources for this one. One of them goes deep into this idea of charge imbalances in the air and how you can use them to like build up an electrical charge.
Clever.
Yeah, and the other one looks at it from like a more natural perspective.
Okay.
Kind of inspired by how trees work.
Wow.
Yeah, using grounding and even mixing in some electromagnetism.
So we're going to look at how to make these things and the science behind them.
Exactly. That's the mission for today.
I'm excited.
Okay, so this first source jumps right into this idea of using the charge imbalance in the air
Okay.
and this thing called coherence.
Right?
So what is that all about?
Well, most people think that air is electrically neutral, right?
Yeah, I guess so.
But it's not.
It's not.
No, there's actually all these little charges floating around.
Really?
Yeah, from all sorts of things like cosmic rays and even just natural radiation.
Wow.
And the trick is to find a way to separate those charges, the positive and negative ones, so that you can harness that difference, that electrical potential.
So that's where this atmospheric energy harvester pole comes in.
Exactly.
And it has these different layers. Can you break down what each layer does?
Sure. So picture a pole, right, standing upright.
Okay.
And at the very top is the air charge collector.
The collector.
And this is made of a special material that's really good at grabbing onto positive charges.
What kind of material are we talking about?
Well, they suggest things like silica aluminum or even a superfine mesh. They call it a nanomesh.
A nanomesh.
Yeah, and it's designed to trap moisture too because, humidity actually helps with this whole ionization thing.
So the moisture makes it easier to collect those positive charges.
Exactly.
Very cool. What happens next?
Okay, so now you've got all these positive charges building up on the top layer.
Right.
But you don't want them to just mix back in with the negative charges and neutralize, right?
Of course not.
So that's where the middle layer comes in.
Uh-huh.
This is the charge separator and coherence optimizer.
Okay, break that down for me.
So it's basically a barrier made of something that doesn't conduct electricity very well.
Okay.
An insulator, they call it.
An insulator.
Things like glass mica or even some high-tech polymers could work.
Interesting.
And the point is to keep those positive and negative charges apart.
Gotcha. So it's like a wall between them.
Yeah, you could say that, but there's more to it than that.
Really?
Yeah, see, this layer also helps with coherence.
Coherence.
That's about maintaining the organized state of the energy you've collected.
I see. So it's not just keeping the charges separate, it's keeping them in a usable form.
Exactly. If the energy gets all jumbled up, it loses its...
It's like herding cats. You got to keep them all moving in the same direction.
That's a good analogy.
So we've got positive charges on top, separated by this insulator, and then what's at the bottom?
The bottom layer, that's where we collect the negative charges.
So it all comes together.
This layer is made from stuff that attracts electrons like it's going out of style.
Okay. What kind of stuff are we talking about here?
They suggest graphene, which is like this super material.
Yeah, I've heard of that.
Or a gold-coated surface, or even carbon nanotubes.
Wow. All very high tech.
Yeah, they're all really good at grabbing those electrons and holding on to them.
Okay, so now we have positive on top, negative on bottom, kept apart by the insulator. What happens next?
Well, now you've got a voltage, a difference in electrical potential between the top and bottom layers.
Just like a battery.
Exactly.
But how do we actually use that energy?
That's where the grounding system comes in.
The grounding rod.
Yeah, usually it's just a metal rod driven into the ground.
Right.
But it plays a crucial role. Well, first of all, it creates a stable reference point for the whole system, electrically speaking.
A kind of baseline.
Right, and more importantly, it provides a path for those electrons to flow.
I see. So when the charge difference gets big enough, the electrons can flow through the grounding rod.
Exactly, and that flow of electrons, that's electrical current.
And we can use that to power things?
Exactly, you can store it in a battery or use it directly.
Okay, so let me make sure I understand this. The air naturally has these charges. The top layer grabs the positive ones, the middle layer keeps them separate, the bottom layer grabs the negative ones, and then the grounding rod lets us tap into that flow of electrons.
You got it.
That's pretty amazing. It's like we're squeezing electricity out of the air.
In a way, yeah.
So this source says this design is viable. Why do they think it can actually work?
Well, they point out a few things. First of all, we're talking about a constantly renewing resource, right? The air, exactly. The air is always going to have these charges because of all the natural processes going on. And that middle layer, the insulator, is super important because it prevents those charges from just recombining.
Makes sense. You don't want to waste the energy you've collected.
Exactly. And the materials they choose for the top and bottom layers are carefully selected to be really good at exchanging charges with the air.
Uh-huh.
And here's the coolest part. It's self-sustaining.
Self-sustaining, what does that mean?
It means you don't need any external power source to make it work.
Really?
Yeah, the whole process is driven by the natural conditions in the atmosphere.
Wow, that's pretty incredible.
It is.
Okay, so let's move on to the second design, the one inspired by trees.
Okay.
This one seems to take a broader approach.
Yeah, it's really interesting.
And what's the thinking behind it?
Well, they started by looking at trees as these tall structures rooted in the ground,
Right.
and they realized that trees are constantly interacting with the atmosphere's electrical field.
That makes sense.
So this design tries to mimic that in a few key ways.
Okay, like how?
First, they make it tall to take advantage of the increasing electrical potential as you go higher.
So like the taller the tree, the more energy it can potentially access.
Exactly.
Interesting. What else?
Second, they focus on a strong grounding system for stability and energy transfer.
Just like the roots of a tree?
Right. And third, they don't just rely on static charge separation. They use multiple methods to harvest energy.
Multiple methods, like what?
They use both electromagnetic and electrostatic principles.
So it's a more diverse approach to energy capture.
Exactly.
Okay, so this atmospheric energy harvester pole design is quite a bit taller than the first one.
It is, yeah. They're proposing a height of 12 to 15 meters.
Wow, that's pretty tall.
Yeah. And the main material they use is carbon fiber composite.
Carbon fiber, that's some strong stuff.
It is. It's also lightweight and doesn't corrode easily, which is important for something that's going to be exposed to the elements.
Right, so why do they need it to be so tall?
Well, remember how I said the electrical potential increases with altitude?
Yeah.
That's why they want to reach up higher to tap into a stronger electrical pressure difference.
So it's like getting water from a higher point in a water tower, you get more pressure.
Exactly.
That makes sense. So what's going on at the very top of this pole? How are they capturing the energy up there?
Okay, so at the top, they have this really sophisticated charge collection system.
Layered, I bet.
It is, yeah. First, they have a copper mesh, because copper is a fantastic conductor of electricity. Then they coat that with titanium dioxide, or TiO2.
Titanium dioxide.
Yeah, it's this photocatalytic material, which means it can create electron hole pairs when sunlight hits it.
And that helps with charge separation?
You got it. And then on top of that, they add a layer of graphene-enhanced conductive polymer.
Graphene, again, that stuff is everywhere.
It's amazing stuff. It helps move those electrons across the surface really efficiently.
So they're using multiple mechanisms to maximize the charge they can collect.
Exactly. They even talk about potentially using some photovoltaic and triboelectric effects, too.
Triboelectric, isn't that like when you rub a balloon on your hair and it gets staticky?
Yeah, exactly. It's generating charge through contact and separation.
So even the wind blowing across the pole could contribute to the energy capture.
That's the idea.
Pretty cool. And they're not stopping there, are they?
Oh, no, they're always looking for ways to improve it.
What?
Well, they suggest gold plating the copper mesh to prevent oxidation.
Smart.
And using a special kind of TiO2 that works better in low light conditions.
Interesting.
And even laser texturing the graphene to increase its surface area.
Wow, they're not messing around.
Nope. They're all about maximizing that initial energy capture.
Okay, so they're collecting all this charge at the top, but how do they turn it into something usable?
Okay, so this design uses two main methods, electrostatic harvesting and electromagnetic harvesting.
Two methods, tell me more.
So for electrostatic harvesting, they have these arrays of little capacitors along the pole.
Capacitors like tiny energy storage units?
Exactly. They charge up from the atmosphere's electric field. And then they have these super sensitive circuits called electrometers that can measure and manage those tiny currents.
Wow, very precise.
Yeah. And they even suggest optimizing the capacitors with a special ferroelectric polymer layer to hold even more charge.
So they're squeezing every bit of energy they can out of the air.
Pretty much.
What about the electromagnetic harvesting? How does that work?
So their first thought was to use magnetic flux density sensors and coils to tap into the low-frequency electromagnetic fields that are always around us.
Interesting. So they're not just going after the static charges, but also this background electromagnetic energy.
Exactly.
Lever.
But they actually think a toroidal inductor array would be better.
A toroidal what?
It's basically a coil shaped like a donut.
A donut coil. Okay.
Yeah, they think that shape would be more effective at concentrating the electromagnetic energy.
Fascinating. So they're collecting energy in all sorts of ways, but all that energy has to go somewhere.
You're right about that.
How do they handle the grounding and energy transfer in this design?
Grounding is super important, especially with a tall structure like this.
For safety reasons, I imagine.
Exactly. They don't want any stray currents running around.
Of course.
So they have this heavy-duty copper-clad steel grounding rod driven deep into the ground,
How deep?
at least 3 meters, with radial wires spreading out from it to make a really good connection with the Earth.
So it's like a super grounded tree.
Yeah, you could say that.
And what about getting the energy from the top of the pole to where it's needed?
They have an energy conversion circuit for that.
What does that do?
It takes the energy from all those different sources and converts it into a usable form.
Okay.
They use an MPPT converter, which stands for maximum power point tracking.
Catchy.
Yeah, it's basically a smart system that optimizes the energy transfer.
So it gets the most out of the available energy.
Right, and then they use an inverter to convert the energy into AC or DC, depending on what you need it for.
That's really thoughtful. They've thought of everything.
It seems like it.
They even have some ideas for making the grounding system even better.
Yeah, they talk about a graphene-coated ground plate to improve the electron exchange with the Earth.
Graphene, again, that stuff is amazing.
It really is. And they even mention a fractal grounding system, which is even more complex.
A fractal grounding system, what's that?
It's a multi-layered system designed to be super efficient at transferring energy to the ground.
Wow, they're really pushing the boundaries here.
They are.
Okay, so we've got all this energy being collected and converted, but it all sounds very complicated.
It is. There are a lot of moving parts.
How do they manage and control the whole system?
Well, they have this special microcontroller that acts as the brain of the operation.
A microcontroller, like a tiny computer.
Yeah, exactly. It's constantly monitoring the charge gradient, optimizing the energy conversion, logging data, and running algorithms to maximize energy capture.
So it's like the conductor of an orchestra, making sure everything works together harmoniously.
That's a great analogy.
And it gets all its information from a network of sensors all over the pole.
Right, they're measuring things like temperature, humidity, and wind speed.
So it knows exactly what's going on at all times.
Yeah, and they even talk about using AI to make it even smarter.
AI, that's pretty advanced stuff.
It is. They think an AI controller could learn from past data and predict changes in the atmosphere to get even more energy.
Wow, that's impressive. And they even have an idea for self-adjusting collectors.
Yeah, they call them piezoelectric auto-adjusting collectors.
What does that mean?
It means they can physically move and reorient themselves based on the changing conditions.
So they're like little robots that can find the best spot to collect energy.
Pretty much.
That's incredible. So with all this amazing technology, what kind of performance are we talking about?
Well, the source estimates they could get an average of 5 to 7 kilowatt hours per day.
From a single pole.
Yeah, with a peak output of around 1.2 kilowatts.
That's a decent amount of energy.
It is. And they think the overall efficiency could be between 12 and 18%.
Not bad. And of course, the actual performance would depend on where you are and the weather conditions.
Right. But those are some pretty encouraging numbers.
They are, especially considering it's all coming from thin air.
Yeah, exactly.
Okay, so let's talk about practicality. How would they make sure this thing is safe and reliable in the long run?
Safety is definitely a top priority, especially when you're dealing with electricity.
Of course.
So they've built in a bunch of safety features.
Like what?
Surge protection to handle sudden voltage spikes. Electromagnetic shielding to protect the sensitive electronics.
Okay.
Automatic shutdown if the weather gets too crazy.
Makes sense.
And a really sophisticated lightning dissipation system.
Lightning dissipation, that sounds intense.
It is. They even suggest a plasma discharge shield for extra protection.
A plasma shield? Wow, that's straight out of science fiction.
I know, right?
And what about maintenance?
They plan on doing regular inspections, of course.
Yeah.
And annual system diagnostics using all those built-in sensors.
Makes sense.
And they've designed it to be modular, so if something breaks, you could just swap out that part.
That's smart. It makes repairs a lot easier.
Yeah, so they've put a lot of thought into making it practical and long-lasting.
It sounds like it. So who would benefit most from this kind of technology?
Well, they mentioned a few different scenarios.
Okay.
Like remote locations and off-grid communities where it's expensive or difficult to get traditional power.
That makes a lot of sense.
And it could also be used as a supplemental energy source in places that are connected to the grid.
Right, so it could help reduce our reliance on fossil fuels.
Exactly. And it'd be great for research installations that study atmospheric electricity.
Yeah, so it has a lot of potential applications.
It does.
Okay, so we've looked at two very different designs for harvesting energy from the atmosphere.
Right.
One focused on charge imbalance and coherence, and the other using a more bio-inspired multimodal approach.
It's amazing how they both tackle the same problem from such different angles.
It is, and they both have their strengths. What are some of the synergies between these two approaches?
Well, the first design is all about simplicity and elegance.
Right.
It's a very direct way to capture energy.
And the second design is more about comprehensiveness and adaptability.
Exactly. It's like they're casting a wider net to catch as much energy as possible.
I like that analogy, and the cool thing is they can learn from each other.
Definitely.
For example, all those advanced materials and control systems from the bio-inspired design could be incorporated into the simpler design.
Absolutely. That's where the real innovation happens, when you combine the best of both worlds.
It's like cross-brooding plants to create a super crop.
Yeah, exactly.
And if we can really make atmospheric energy harvesting work, what kind of impact could that have?
Well, it could be huge. We're talking about a completely new way to generate clean energy.
A game changer.
Yeah, a game changer. We could have standalone power sources anywhere we need them.
No more reliance on big power plants.
Exactly. We could power remote communities, off-grid homes, even entire cities with clean energy from the air.
That's amazing. It would change everything.
It would.
This source even talks about a redesigned system that could power an entire household.
Yeah, they're ambitious.
They envision the super tall pole, 25 to 30 meters high.
Wow. It's getting up there.
Yeah, it would use multiple harvesting methods, not just atmospheric, but solar, wind, and even thermal.
So it would be like an all-in-one energy solution.
Exactly. And they would use the most cutting-edge materials like quantum and nano-engineered stuff.
They're not holding back.
Nope. And they would have an AI-powered control system and a massive 50 kilowatt-hour battery.
That's a serious battery.
It is. They think this system could generate 35 to 40 kilowatt hours per day with a peak output of 3.5 to 4.5 kilowatts.
That's enough to power a whole house.
It is, and they think the efficiency could be as high as 22 to 28%.
Those are some impressive numbers.
They are, and the multimodal approach makes it more robust.
Right. If one energy source isn't performing well, the others can pick up the slack.
So it's more reliable overall.
Exactly.
It's pretty mind-blowing to think that we could be on the cusp of something so revolutionary.
It is.
So let's recap. We've explored two fascinating designs for harnessing energy from the atmosphere.
One focused on charge imbalance and coherence, and the other on bio-inspired multimodal harvesting.
And the takeaway is that this technology has the potential to completely change the way we think about and access energy.
Absolutely.
We could have clean, localized power everywhere.
Imagine a world with no power lines, no sprawling power plants, just these elegant energy harvesting structures blending seamlessly into the environment.
It would be incredible. What kind of future could we create with that kind of freedom?
The possibilities are endless.
Food for thought for everyone listening. What would you do with a world powered by the air itself?
It's a pretty amazing thing to think about.
It is.